In this lesson, we're going to start off looking at the properties of quadrilaterals, make sure we understand them and how they're related. Then we're going to determine how to figure out the area and perimeter of some basic quadrilaterals, specifically the parallelogram, rectangle, and square. And in a separate lesson, we'll come back and look at the trapezoid. Okay, so let's make sure we have an understanding of just what is a quadrilateral. So a quadrilateral is any figure that has four sides. It has to be a closed figure, has to have four angles, and it has to also have vertices. So remember, a vertex is just where two sides connect. So in that figure, that would be a vertex. That's the singular form. And so when we have multiple vertices, we call it vertex. More than one vertex means vertices. Okay. The sum of the angles in a quadrilateral is 360 degrees. That's just a fun fact. Okay. We're not going to talk about formulas for area and perimeter right now, but we're just getting to know these. A parallelogram, okay, has four sides because it is a quadrilateral. And in addition, it has opposite sides that are parallel. So this side here and this side here are parallel to each other. It also has opposite sides that are congruent. If you're not familiar with that word, congruent means exactly the same length, exactly the same everything about them, same shape, same size. Okay. It also has opposite angles that are congruent. And so when we're talking about opposite angles, we mean like this corner here and that corner here, they have the same angle measure. And this angle here and this angle here have the same angle measure. Okay, when we're talking about the height of a parallelogram, that is known as the distance between two parallel sides. So if these two sides are parallel, I would have to measure straight down, okay, at a right angle in order to get the height of it. And we'll be talking about that. A trapezoid is a quadrilateral, four-side figure, but it only has one pair of sides that are parallel. So it would be in this one, this side and this side are parallel to each other. And its height is the distance between the two sides that are parallel. Okay, a rectangle is a quadrilateral and it has opposite sides that are parallel and it has opposite sides that are also congruent, but the difference between a parallelogram versus a rectangle is the angle measures are all 90 degrees in a rectangle. Okay, and then we have a square. And a square, the difference between a square versus a rectangle is that it has all the sides that are congruent. So every single one of those sides in a square is exactly the same measure, in addition to it having four angles that are all 90 degrees and opposite sides being parallel. So we're going to go ahead and we're going to look at the formulas. And let's go ahead and look at this. Okay, so for a rectangle, the area is B times H. B represents the length of the base. H represents the height of the rectangle. And in a square, the area is the length of a side squared. And we'll talk about where it comes from in a minute. But, okay. And then for perimeter, this is the summary of how you get it. But basically, it's add up all the sides. But because opposite sides are congruent, we get two bases and two heights, which is where we get the formula from. And for a square, because again, all the sides are exactly the same, if we add up the same number 4 times, we get 4 times the length of one side. So the expectation when you're working in geometry is that you're going to write your formula down, and that's because sometimes people make a mistake by using the wrong formula. So what formula did you use? Make sure we know. Next step is you substitute into the formula, replacing the variables with numbers from the figure. Next, you're going to evaluate, or you may need to solve the equation that results. You verify your solution, does it make sense for the problem? And then you write your answer or your solution with the appropriate units. Okay, so what is the name of this figure? Okay, so first let's make sure that you understand what this little thing here means. So when we have a shape and we put these little tick marks here, everything marked on that polygon, okay, has one tick mark, okay, when we're going through a side, means that all of those same lengths have the same measure. So if this side here is 4 centimeters, then this side is also 4 centimeters because it has one tick mark. This side is 4 centimeters because it also does, and this side is 4 centimeters. So we're going to go ahead and, because we know it is a square, because all the sides are congruent, I know that the area of a square can be found by doing the length of one side squared. And we know that the length of one side is 4 centimeters. We do not put the centimeters in our formula. And it says we square. So remember, squaring means to multiply the number by itself twice, which means 4 times 4. 4 times 4 is 16. So that is not my complete answer yet, because remember, I need to go ahead and make sure my answer makes sense and write my answer with my units. So it does seem 4 times 4 is 16. That's really not much to verify there, but I want to write my answer with my units. So what area, remember, means is I'm cutting this up into little teeny squares that are 1 by 1 centimeter. So it's how many square centimeters. So for area, my units always have to be square units. So I'm saying my area is 16 square centimeters. And that would be my final answer. So what about the perimeter of this square? Well, the perimeter of a square is just the length around. So if I was walking around here and I started right here, I would have walked 4 centimeters and then another 4 centimeters, another 4 centimeters, and then another 4 centimeters. So I would go 4 plus 4 plus 4 plus 4, which means I added 4 times. And that's why to find the perimeter of a square, it's always 4 times the length of one side. So to find the perimeter of a square, I just do 4 times the length of one side. In this case, it's 4. It's equal to 16. And I'm not walking in a bunch of squares. I'm just walking straight down a path. So it's not square units, but just centimeters. Okay, it's not always necessary to have the picture in front of you. Sometimes you may just have a verbal description. So this one says, determine the area of a square with a side length of 3 8/10 feet. So sometimes, for some people, it helps. So it doesn't have to be a beautiful picture. Just draw it. And it says it looks like a square, 3 8/10 feet. All the sides are congruent because it's a square. So now we're going to go ahead and we do it. Okay, so what is our formula? Area is side squared. I substitute side squared. I evaluate. That means do the math. I get 14 44/100ths, and now I need to go ahead and use my units. It's feet but because it's area, it's units squared. Now here's the more challenging problem. This one says determine the area of a square that has a perimeter of 24 and 8/10 inches. Now how could we go ahead and do that? Well, we're going to have to work a little bit backwards. So let's go ahead and try and figure it out. So we know it's a square, and we know if the perimeter means that I've gone all the way around it and I took 24.8 inches. Well, I know that the perimeter is 4 times the length of one side, and I know that this number represents the perimeter. And I know that 24 and 8/10, okay, is equal to 4 times the length of one side. So I can use some algebra to figure out what the length of one side is, because the inverse of multiplying by 4 is dividing by 4. So if I do 24 and 8/10 divided by 4, I would get 6 and 2/10. And then 4 divided by 4 would be 1. So I get that the length of one side is 4. And to double check, if I do 4 times 6 and 2/10, 4 times 6 is 24, 4 times 2 is 8, so that gives me 24 and 8/10. So I know that the side length is 6 and 2/10 inches, but that's not the question. The question says to determine the area. So now what is the area? Well, area formula says for a square, the length of one side squared is how I figure out what the area is. So now that I found the length of one side, I could go ahead and I could replace the side length with the 6 and 2/10 and square it. So when I go ahead and I do that, I get 38 and 44/100. Now I have to put in my units. Because this time it's area, it's not inches, but inches squared. So what is the area of a square that has a perimeter of 24 and 8/10 inches? It is 38 and 44 inches squared. Okay, so let's go ahead and figure out the area of this shape. Well, make sure you recognize it, not a square, and this time it is a rectangle. And so notice that this has 2 tick marks, but this is 1, and that's because these 2 sides with 1 tick mark are both going to be 25 feet, and the ones with 2 tick marks would both be 10 and 2/10 feet. Okay, so if we're going to start off doing area, formula for area is base times height. Now for a rectangle, because every angle is a right angle, it doesn't matter which one is the base and which one is the height. So this could be my base, this could be my height, or it could be the other way around. And that's because multiplication is commutative and both of them are perpendicular to each other. So we go ahead and we do area, 10 and 2/10 times 25. We calculate that, and we get 255. And now we go ahead and include our units. So that would be feet squared because it's area. Okay, now what about the perimeter? So perimeter is twice the base plus twice the height. So we said that 10, oops, 2 times the base plus 2 times the height, and 10 and 2/10 we use as our base, and 25 is our height. And so now we do 2 times 10 and 2 tenths, 20 and 4 tenths, 2 times 25, 50. Add them together, 70 and 4 tenths, and because this is perimeter, it's a linear unit, so it's just feet. So our perimeter is 70 and 4 tenths feet. So what's the area of a rectangle with a base of 18 and 4 tenths millimeters and a height of 4 and 9 tenths millimeters? Okay, so without a picture, we can still do this because it says a rectangle, and we know the area formula for a rectangle is base times height, and we know that the base is 18 and 4 tenths, and the height is 4 and 9 tenths. And notice I'm not using the dot for multiplication and putting parentheses because dots get confused with decimals. So 18 and 4 tenths times 4 and 9 tenths, and I get 90 and 1600ths, and my units is millimeters squared. Okay, so Jennifer's purchasing mulch for her flower beds. Each bag of mulch covers 25 square feet. Her flower beds measure 10 feet by 3 feet, and she has 2 of them. How many bags of mulch does she need? Okay, so let's go back and review. So each bag of mulch covers 25 square feet. Her flower beds measure 10 feet by 3 feet. And she has 2 of them. That's a number. And our question we're trying to answer is, how many bags of mulch does she need? So sometimes it helps if you draw a picture. Doesn't need to be anything fancy. And so we know that the flower beds are 10 by 3 feet, and there's 2 of them. So it says if each bag covers 25 square feet, that's telling us that it's area. So we need to know the area of each flower bed. So the area of this would be base times height, and that would be 10 times 3, which is 30 square feet. They're exactly the same, so there's 2 of them. So if I do 2 times 30 square feet, I get 60 square feet. Now, that is not the answer, because the question, remember, is how many bags do I need? Well, 1 bag is 25. 2 bags would be how many? Another 25, so that would be 50. And that's not enough. I can't buy part of a bag, so if I get a 3rd bag, I have 75 square feet, which would be enough. So my answer would be that Jennifer needs to purchase 3 bags of mulch. So the area formula for a parallelogram is same as a rectangle. But remember, a height, it's necessary to have a connection that is 90 degrees to a base. And that's where we have a little bit of trouble in parallelograms, because rectangles always have 90-degree angles, but parallelograms don't. And so we need to look for the height in a different way. height of a rectangle, remember, it's the distance between two parallel sides. So we're normally going to see it inside the parallelogram. Sometimes you might even see it outside the parallelogram, but you're always going to see some type of 90-degree angle measure indicated with a little square on it to tell you this is the height. Okay, so our area formula, remember, is base times height. Now there's 3 numbers here, but we only need 2 to find the area. So remember, one of them needs to be our base. The other one needs to be our height. Well, the height is the one you have to be careful about with the parallelogram. Always look for your right angle. Your right angle will connect your base and your height. So the 2 values connected by the right angle are my 9 1/10 and my 12 3/10. The 12 3/10 is part of the parallelogram. That's what tells me it's my base. The 9 1/10 is a measure between 2 bases, and that's what tells me it's the height. So 12 3/10 times the height, 9 1/10, gives me an area of exactly 202 9/100 inches squared. Now, the perimeter, because we don't have bases and heights that are outside of the parallelogram, we can't do our measurement of our perimeter the same way we do for a rectangle. So we're just going to go ahead and add up all the sides. And that's basically what you do for anything that's not something that has a formula. So if I wanted to figure out the perimeter, I would just add 12 3/10. And this side is congruent to that, so I add it twice. And then this is on the outside, and opposite over here is congruent. So I would add 9 8/10 twice. So I would get 19 6/10, and my units would just be inches. And sometimes for parallelograms, it's pretty easy when they just give you the words. So, but if we wanted to draw a picture of this one, parallelogram, base is 3.9, height, and the height can be kind of anywhere in it, 5 5/10 meters. And just in case you didn't know this, again, just to kind of re-emphasize, the height for a parallelogram doesn't even have to be inside. Sometimes you might see something like this, where it's actually drawn outside. It still is a height, but the key is looking for that right angle. Okay, so area is base times height, and then we computate, and we get 21 45 hundredths, and it's meters squared. Okay, and here's our summary, and we will be doing trapezoids another day.